Hey guys, welcome to devops school. In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in devops school certification level courses which will help you to emerge skills for a wide range of entry level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai, and in Pune. Simply compare our many courses, find the one that suits your style and schedule best, and start today.
So it will be so fast, you'll not be able to create a commands immediately. So kubectl roll out -h, and this is the undo command. This is a status command, and this is status and history command. Just a second. Rollout, undo -h. All these commands I need it here. This is the status command, right? So I'll just get this kubectl get deploy -n is equal to Rajesh, and here my dep. So my dep deploy, this I will copy here as well, this I'll copy here as well. Okay, I think this is not needed anymore. So I'm going to check out the status and I'm going to check out the undo stuff. So this one. Okay, now status, undo, and one more time status. Okay, so now what is happening? First understand this one of the deployments. Let's check it out. So here describe deploy and a name of the deploy, my deploy. Okay, -n is equal to Rajesh. Here if I look at this rolling update strategy, this is important to understand. So how many strategy we have, we need to check. Okay, this is important. So now rolling update strategy. So what is the strategy? How many strategy we have? As of now, till last month I checked, it was having only one. So can we do one thing? Can we get it? So for that, I will write a command here, explain dot deploy dot spec dot. Okay, let me check till here. Okay, clear the screen here. What is this? Explain deploy, sorry, spelling mistake, dot spec. So I think it should be a space here, my bad. So clear the screen. Now you see here, and underneath strategy, spec dot strategy, and here you see rolling update strategy. Now rolling update strategy, how many strategies you have? Only one strategy, rolling update strategy. You see here, rolling update strategy, only one you have, correct? Rolling update. So if you see here, strategy dot rolling update, so you can run these commands actually. which will help you to get this done. Now, if you look at this here one more time, if you look at this here, you have a two fields, max surge and max unavailable. Okay, so what is this max surge and max unavailable? Here it's in percentage, it can be in a number of pods also. So here, this strategy which I'm going to discuss right now. So let's say, understand this. Here we have deployment, okay, and this deployment is the image number 1.2, 1.1. Now here, how many pods we have? Let's say 10. Let's make it 12. That will be easy for me. 12. How many pods we have total? 12. So total 12 pod is there. Okay. So now here I said 25% unavailable, 25% search. So what is the meaning of it? So now I want to deploy rollout 1.2. So there's only one strategy right now available. So when you deploy 1.2, what happens? First, they delete 25%, and then they create 25%. See that together it's become 100%. Correct? Like this. Okay. Are you getting my points here? What I'm trying to say? Okay. After that, again they delete. Sorry, they do delete one more 25%. Then they add one more 25%. They delete one more 25%. They add one more 25%, and then this one and this one. So this way, you think, what is the advantage of this? This way your application is never ever down even for 1 second. Are you getting, guys? This popular
Yeah.
feature. So this is called rolling 25% max unavailable, 25% max search. You can set 50, set 20 also. By the way, you can set here 5 pod also. Here you can say 5 pod also. That means 5 max unavailable means 5 they will delete, 5 they will add. So percentage and number of pods you can write it. Okay, so this is the one. So now what I'm going to do is I am going to do the rollout. So all of my commands are ready already to copy paste. These are the commands I needed. Now look at this here. So get a deploy, explain, get deploy -n is equal to Rajesh. Here you have 2, right? Now I'm going to make it 20. Okay, so the command somewhere scale, and which image I forgot. So let me do one thing. Let me delete this one. Let me create from the scratch. Delete mydep and -n is equal to Rajesh. I deleted this one. I will create one more. Deploy. I'll create one more. So here I'm going to create a deployment. This one deployments I'm creating, and how many scale I want to do. I want to scale. Okay, so now, okay, now here I want to scale for 20. This all commands I'm making ready, so I'll run it. Okay, and then I will change the image. So this is the image, edit, deployment, my deployment, and then I will run this command, status, okay, and then I will do undo after saying the history. So here undo, history command is somewhere here. So history and then undo, okay, undo to whatever it is, and then again status and like this. So all the commands are ready to execute. I hope you understood. Now I'll tell you. So here I'm creating one deployment, okay, with a v1. Okay, so here done created. I am creating scaling. I'm checking the status. Okay, status also you have to add -n. Okay, so now I'm going to check the status. See here, rollout successfully. Now I'm going to replicate to 20 and the status. Look at this. So you can see that how this progress of rollout. Right now 1 to 20 is being rolled out. Okay, 1 to 20. So it's updating the replicas. Okay. Okay, now rollout successfully happened. So you can see it also right now 20, but in real time we'll do 2000 and all stuff like that. Okay, now you see the status one more time, and here it got successfully rolled out. Now I'm going to edit the image. Okay, so here I'm editing the image. Go to the version 2. So
Gone up, I guess.
here version 2 I did. Now you see here status quickly. It's just I spent time. Okay, look at this here. Oh, by mistake I did. See, if I want to do rush, definitely something bad happen. See, still happening. So see, 17, 18, 19. Now it's done. So now it's updated this stuff. Now you're going to check the history. So basically 25% I wanted to show you. So 22. Okay, now I'm going to roll out to the 2. Okay, 1 and 2. So here 1. Okay, so now you are in 2, 1. Again, there's n is missing. And here, okay, this is the script because this is the same one. So here it should be 1. Sorry, I missed it. Roll back. Now status quickly. See here. Now it's happening. See, replicas has been updated and all. So this is how you can check from the version 1 to version 2, and always down in a 5 series, 25%. Remember, 25% and status. Okay. So now this is the rollout and rollback. This is the rollout, rollback, and this is a rollback, and this is the rollout. Okay. So done. So all together, this is the stuff which we have done it. Now, one more thing I would like to show you. We've been playing with the deploy, right? But how about this YAML file? How do you create it? So there is one cheating I will teach you. If you want it, what you want to do? You want to generate a YAML from the existing product. You can do that. So kubectl get a deploy, and here get a deploy, and here -n is equal to Rajesh, and here get a deploy but my dep. Okay, this is the, so get a deploy my dep and -Rajesh. So see here, this you are seeing. Now what I will do, I will output to this one, to the YAML file. Okay, and you'll see something like this. But here you have a status information, runtime environment also, which I don't want. So if I do --- export, I will get this status removed. See here, no status. Every status got removed. Now you can copy this whole things in the YAML file. So what you can do, copy this whole things into one of the YAML file, which is, you can call it dep.yaml. Enter, and here it is, dep.yaml. Here it is. So now this is the YAML file. You can change it and do the things whichever you want. So let me delete the older one, and look at this YAML file very carefully. Okay, here some strategies are there which you can modify if you really want to. See here, this revision history 10, all this thing, rolling update. If you want to modify this, you can modify this, all this stuff. Now let me delete the older one and recreate from once again. So here kubectl delete deploy and my dep and -n is equal to Rajesh, -n is equal to Rajesh, and here I deleted. Now I don't have that, I can recreate from here. So kubectl, remember the command apply, create, all this thing, kubectl apply -f and dep.yaml -n is equal to Rajesh, and then you see that how it is easy to work with, and you can do the little bit of cheating also and then get the YAML file within no time right now. So guys, did you understand this, all of it? Yeah. Okay. So
Yes,
here,
yes. In case we have only,
sir.
Rajesh, in case we have only one pod, okay. So in such case, we have to upgrade it. So in such cases, will it create any backup or 100% will replace?
No, the replication will not create a versioning. It will not create a versioning. Okay, maybe I do not understand your question.
No, my question is actually now we are doing the this thing right. Say versioning when you're doing it. In case I have only one instance.
One
In
pod.
one instance, I am upgrading from one pod from version 1 to version 2. In such cases, entire 100% has to do it, right? Maybe
You cannot do that, no. You cannot do that because the pod which is created by deployments is managed and controlled by deployment controller. So the moment you change those pod manually, immediately deployment will create a new pod, and that will become an obsolete pod. You cannot do that, right?
Okay.
Pod you cannot modify.
So
The moment you modify the pod, so there is no way you modify the deployments actually.
Sure. Okay.
Understand that?
Fine.
Understand the rule of the Kubernetes.
Fine.
Rule of the Kubernetes says whatever you have desire, that means you wanted to have a YAML file, I mean deployment with the 20 pod with this nature. So if anything get compromised, immediately they will throw that pod out of that controller and then replace with the new pod if you modify the some pod manually.
Okay.
Okay, quick question. The normal strategy for replacing pods with new versions seems to be first delete and then create the new batch of pods. With a single pod, what happens? If you're upgrading a deployment, a single replica.
Single replication immediately will be respond. I mean, it will do that thing. But deployment is basically, remember, if you have a single pod, that's okay. You get it done, but deployment is basically for the multiple pods. You can have a single pod deployment also, but typically we don't use it for this.
The other question I have, when you do this command to generate the YAML file from the configuration, it adds a lot of fields, including tags like F, colon, whatever.
Yep, that's correct. Yep.
What is that?
Those are the meta information. So basically, what happens, I'll tell you, you write a YAML file with the required information, but when it goes to the etcd, they fill some of the default values also. So those are the meta information which is there. So when I exported it, I got it back, but this is how it is.
So would it be fine to just delete it when you get it exported?
No, there's no as such there's no as such command I have come across. Maybe
no,
it's
I mean
there.
Manually.
Manually, yeah, you can do that manually. Yeah, manually you can modify whatever you want.
Basic point is if it would impact the deployment later. Basically, I want to clean up the deployment after getting it exported. So I wanted to know if I can delete the managed fields section. Yeah, that section there.
Yeah. These are the fields which is basically for empty one. So I need to check if some commands are there to delete. So without any error. But again, it's a YAML file. You can take the entire field off also. managed field you can completely delete, and it will it's just a cleanup. So you have to take the entire field off from here till here.
Okay, thanks.
Yeah, that will work. In when you write a deployment, typically you won't get it, but from the runtime you get it actually. Okay, so this is the guy's deployment. So yep, it has all 5 features we discussed about it: replication, controller, versioning, rollout, and a rollback. Okay, now can we move on a service, which is our next topic? Any questions anyone has?
Yeah, Rajesh, there is something called labels and there is something called sectors. What's the difference? Because the name same difference. What's the use of those?
What is it? Labels and
Selectors.
those are the topics, which is the next topic only, our service topic.
Okay, fine.
Actually, label is, I'll tell you in a conceptual way. Any objects you create, you can label it as many times. Let's say my name is Rajesh Kumar. My name is Rajesh Kumar, but you can label me as like a DevOps engineer, or maybe you can label me as a Raj, my nickname Raju also. So it's like this, you're giving the same to identify easily or search easily. You give them multiple tag or something like that. So label is something like that. So here in Docker also, in a Docker also. So any object you create,
so kind of
any object it's any object you create, you can label it as many times you want it, but when to use it, when to use that, the label done. So while you filtering out, right, you have thousands and thousands of pods, so you want to filter it out based upon the labels, so then it is easy. You can filter out that deployment based upon the labels, that is easy. But in the service, basically it rocks. So how it rocks in service, I'll teach you next topic now.
How is it different from selector? Because the value I see both are same.
No. Selector is different, labels are different. I need to talk about it.
Okay, thank you.
Yeah. So selector, right now there is a many selectors actually. So right now I will talk about, today I'll talk about only the label selector, but we have a node selector also, and we have affinity also, anti-affinity also. We have many things are there actually. I'll talk about one by one. Okay guys, let's get started with our next topic, which is service, which I was holding so far. So a little bit of this.
Yeah, we talked about pods being deleted 25% and created 25% at a time and all that, right? When a change is happening. So
yes.
This point, the IP of the pods also change, right?
Yes, IP address also get changed.
So if I have another microservice pointing to this microservice, I have to go and update the configuration of that service, like the new IPs and all that.
The answer is in service. I know that all of your confusion. Yeah,
okay.
Just this service will open up your mind. It's a very powerful service.
Okay, thank you.
Yeah, guys.
It's a microservice.
So here,
let's understand.
Yeah, remember guys, I said Kubernetes is an orchestrator for microservices as well. Yeah, so that's what I'm talking about right now. So see here guys, we talk about lots of things. We talked about today and yesterday. We talk about this. This is me. I have 2 eyes, 1 nose, 1 mouth. I have 1 laptop, and this laptop is called workstation. This workstation has kubelet, and kubelet read the config file. So this is the admin of the Kubernetes. Okay, you know that very well now. Now we also talked about cluster, which is running here. Cluster has a master cluster, master control plane, and this guy manages multiple node. So I'll just change the color for sake of discussion. So this is 1 node, 2 node, 3 node, 4 node, 5 node. All these node are running. It could be 50 node also. Now here what we have: pod, 1 pod, 2 pod, 3 pod, 1000 pod, hundreds of pod, whatever you have pod. So we talk about this runtime. Application is running right now with the help of the deployment. Applications are running with the help of the deployment. Admin has completed work, but why you are running application? Think about it. For whom you are running applications. For whom?
Users.
For
End
user,
user.
right? And yes, for the end user. And
Yes.
users are not inside your cluster. Understand that. Users are not inside your cluster. They are outside. They are outside. They are outside. They are outside. So they cannot access your pod. So now what problem we are solving right now is how users will access one of these pod. Not everything, because you running I don't know which Nginx you running 100, but you don't want to access 100 Nginx. You want to access only one. So that problem is solved by that problem we are trying to solve now. So did you understand that what we are trying to solve? This is the last part of your applications and the user. Make sense?
Technically, it also affects systems that are interacting within each other. Meaning, if you have a service that accesses another service, it would also be treated as such.
Right. Yes. So guys, now let's start discussing about services. So guys, look at this image, very simple image. Look at this node 1, 2, and 2, 6. Now each node, you see there are pods. Few nodes we have a one pod, and two nodes we have a two pod. Okay, look at this here. Pod also image a container. Inside the pod there is a container. One pod, one container. Okay, now if you look at this very carefully, the container, few containers are fe means front end, and few containers are db means database. Okay, look at this. So here you know that pods Kubernetes view entire data center as one computer. You know that Kubernetes view entire data center as one computer. So scheduler may create pod anywhere, wherever they feel alike. Okay, because of they have some logic inside that, based upon the CPU allocations, based upon the RAM allocations, and based upon the number of pods, they allocate the pod to the node. Now you can customize this one, but right now I'm not in a phase of customization right now. Okay, so let's do that. So here we have a node 1, node 2, node 3, node 4, 5, and 6. Each node we have a pod, and pod has a container, and container, the type of the container is fe and db. Now one more thing, important thing you should look at it. Pods are inferal. So if the one pod get replaced, you get a new pod. Yes, you get a new pod. Same pod you will never get it. You would never get it. And new pod, when you get it, IP address are changed. So this is the one scenarios. Now the question is, forget about the end user right now. Question is how the 4 front-end pod will communicate with the 2 database pod. How? Whether they will connect to the first one or second one or first one, how? And this is an image, small image. You have to visualize there are thousands of front end, hundreds of back end. So who will talk to which one? Let's say all the front end pod, if you hard code with the pod 1 of database, then every load will go to the pod 1. If you hard code the IP address of the pod 2, every load will go to the pod 2 of 44, which is ending with it. So it's not good practice, right? This is so much of chaos, right? Did you understand the problem here?
Yes.
So again, you did scaling or auto scaling or rollout. You know what you did earlier? You had a version 1 running with a 2 pod. Now you wanted to run version 2 with the 3 pod. So 1 plus 2, you did not roll out properly. You did not delete the older one. So you got the 1 older, 2 newer. Now here there's a problem. Each pod you get the new IP address again. So here the problem again, major problem is now whether you want to go to v1 or v2. On v2 also, which one? So it's just so much of confusion here for the front end. So how do we manage? Look at the numbers of containers which you are running, pods which you are running, thousands. So which one will connect to which one? So how this give this guidance? And the same problem we had, remember, same problem we had in the during the discussion first day for the managers also. Okay, same problem. So now how do you solve this? Now How do we make sure that all the traffic should be only moving to the V2, not a V1? Again, this problem. So many problems will occur, and the solution is service. Solution is service. So the question is again back to the same. What is service? So guys, service is a managed, again, service is a managed load balancer. Yes, service is a managed load balancer which is created by you but managed by Kubernetes. Yes, it's a free. In AWS, if you create a load balancer, you have to pay for it, $1, I think, per day or something like that. But here it's free. So this service is doing what? So this service has a unique IP address which never ever change. Yes, that's true. The IP address of the service which never changes. Okay, and then it has a fully qualified domain name as well. So now front end pod will not communicate with the backend pod. Yes, no, they will communicate with the service, and service, the one which you see in the middle, will load balance the backend pod. Backend means DB pod. So did you understand what is the service? It's nothing but a load balancer, but managed load balancer by the Kubernetes, free of cost, available. Their IP address never changes. DNS names never get changed. Guys, did you understand the problem, and did you understand the solution also?
Yes.
Now next problem. Next problem. Now next problem is how, because you scale it. You did already scale, so I'm not afraid to talk about the new terminology. You scale 2 to 4. The problem here is, think about it. Problem is that the moment you get the new pod, you get the new IP address. How this new IP address automatically register to service? That's a question. That's a question. That's a question. How the new pod which you added, maybe you created a service by balancing the 2 existing pod, you may hard code the IP address on the service, but how about this your scale from 2 to 4,000? How this 4,000 remaining pods, new pods, will automatically get load balanced by the service? How this can happen? That's the problem. One more problem. Sometime what happens, you have so many pod of the backend, but some of the pods are V1, some of the pods are V2. Now in a simple way, let me tell you, sometime you log into the Google Gmail, you see 50 emails, and again sometime you log in, you see only 25 emails. Will you accept this behavior of Gmail? No, of course not. So this is what is happening in this image. Actually, you have a 4 pod of the backend, and the 2 is older version, 2 is newer version. How this service will only redirect to the older one or newer one? Guys, did you understand the 2 more problem now?
Yeah.
Guys, did you understand?
Yeah, right.
Yes.
Now answer is label rocks. Yes, label is the answer for many questions. So again, in a simple way, before getting into the labels part, let me tell you guys, service is a basically managed load balancer which is managed by Kubernetes, which will help you to load balance your pod, okay, which will help you to load balance your pod, and IP address of the service never change, DNS never change. So all the pods which is load balanced by the service, you can hit to the service and it will redirect to one of the pods, active pods, running pods, whatever it is. But the question is, what about you scale, upgrade, roll out new version, old pod, new pod get added, how you update the service? Those are the things, and that is where the label rocks. So how label works, let's look at this. Here there's a service. Here, look at this service. You have a prod B 1.3. So what they have done, there is a service we have created and we label service. I'm not talking the name, it's a label. You have seen the labels. Some of you have asked also questions. You have seen, so you can label it as many you want it. So here what has happened, you label the service with the prod B 1.3. Again, you had a 3 pod lying and you also label them prod B 1.3, prod B 1.3, prod B 1.3. Look at this one pod has a auth container, another pod has a DV container. So how this label rocks? Please hear me out this statement. It is a wrong statement, by the way, but still I'm telling you, please hear me out correctly. If the labels of pod, matching with the labels of service, automatically load balance, automatically there is a one pod which is there in your there's one software which is there in your cluster that is called core DNS. Have you seen this pod? Anyone? Core DNS? Guys, have you seen this core DNS? Anyone?
No.
No?
It's in the kubeadm namespace.
Let's check it out. First, we should check it out. Actually, let me check.
It's in the kube system namespace.
Yeah, you are correct. You are correct. So kubectl get pod hyphen n is equal to cube hyphen systems. Oh, sorry. Look at this, guys. See here, core DNS. Okay, you must have seen it actually. I don't know, first day itself while running this cluster. Okay, so this is the core DNS. What exactly core DNS is? This is your discovery services. DNS means what? They have a mapping of what? Mapping of IP address and their domain name. But here they manage label name and their IP address. Simple. So what happened? Understand this. The moment you label them, core DNS reads this. What is the label? What is IP address? Like that. So all the records what you have in the core DNS. Okay. So what happens? Please hear me out very carefully. The moment the labels of pod matches with the label of service, automatically this pod get load balanced by service. First you hear me out. I will show you also during the demo. Again I'm repeating. Labels of pod, if it is matching with the service, automatically pods get load balanced by service. How come? Because they get information from the core DNS discovery services. So any pod you create, their discovery services always store that information, what label, what IP address, this, that, and all. So the moment they found out the new any pod get updated with the name of the services service, take it from those IP address from the core DNS service, discovery services, DNS services. Okay. By the way, let me tell you, there is a slightly mistake I am making. Okay, because I want to understand well. I'm using this statement, but little mistake I'm making in the statement, which I'll correct during the demo, because at that time you will see that and you can recollect everything. But is that okay? Did you understand that? Did you understand that how this new pod get introduced and how this automatically get load balanced by the service? Did you understand that? Because of the label. Now who's labeling it? You. Whose job is to label properly? You. Those who's creating pods and services. So you should label it correctly. So tell me one thing, in this image, did we have a right labeling or not? Tell me. Did we have a right label or not?
Wrong.
Wrong.
No,
It's not able to differentiate between
It's not
I don't
correct.
hear you.
Auth and DB having the same label, which is not correct.
We don't have production front end.
So sometimes what happens is the wrong labeling. No, I did wrong labeling. We did wrong labeling. Why? Because sometimes service will rewrite the connection to the DB, and sometimes they will be auth. That means you log into sometime gmail.com and you get sometime some dashboard. So will you accept this one? You want to log in Gmail, not a dashboard. So it's like that. So yes, this is wrong labeling, by the way. It's not a good labeling. So you should do the labeling. That is your work. Everything will be done by Kubernetes, but there's something which you have to done too also, so you can save your job, right? So the labeling has to be done very carefully by all of you. So this is the concept. Now let's move on. See here. See here. There is a 4 pod, and see here, prod B, prod B, prod B, prod B, prod B. Here the labels of pod is matching with the prod B because I removed 1.3. So because of now it's load balancing 4. Load balancing 4. So what I want, either I want the service of 1.4 or 1.3. It should not be it should not be like you sometime old version, sometime new version. So how do we correct it? We relabel the service 1.4, and now you see here it's redirecting only to the right pod, right labeled pod, guys. So now the question is, what is service? Service only send a traffic to the healthy pod. Healthy pod means it's running pod. Again, it can be configured for session affinity also. Again, service can help you to, this is important, third point is important, service can point to things outside the cluster. Yes, and this is what I was talking about to begin the discussion, right? I'm outside.
If you liked our Kubernetes session so far, please enroll for our channel membership 399 plan to get access of all the parts.
I need help to access one of the pod. So who will help me? Service. Service may be used to point the things to outside of the cluster also. And what is the logic for this load balancer? Logic is random load balancing, means 1 2 3 1 2 3 like that. And what it uses the IP address, that means TCP by default. So guys, did you understand what is a service now?
Yes.
Yes.
Okay, so understand that few keywords I did discuss about it. And you can create as many services you want, free of cost. Everything is free. Services are free. Okay, this load balancer is free. So here, if you want to load balance multiple pod, you want to access one pod, not thousands of Nginx, one Nginx at a time, you create a service. But how this service load balance the pod? With the help of the labels. And you do the right labeling, right load balancing will happen. Again, rule is very straightforward. If the labels of pod matching with the labels of service, load balancing happen with the help of the core DNS, which is the discovery services, DNS services in your cluster, that is also free. Okay, now there's a slightly mistake is there in my statement. I will correct it during the demo because I want to show you and then correct it. Okay, so this is the service. So did you understand this? This is the service. Any questions?
No.
Okay guys, so I think deployment I already covered. All this thing I've covered. Let me move on. Yeah. Okay, so yeah, so now next question is, how do we do this service? So let me do this service now. I want to show you one by one, step by step, everything. So please focus on my screen. Let me tell you guys, this is the most important topic of your Kubernetes, most important one. Okay, and trust me, I struggled for 6 months at least to understand this concept. So even I used to get very, because at that time the document also not so clear and stuff like that. So here, how do we create a service? So guys, I think create command is one of the fantastic way to create a service. Why to use YAML? Though you can use the YAML also, that's not a very big deal. You can find a hell lot of examples on the website. kubectl create -h. Okay, so I did. Can I create a service or not? Yes, I can create a service. So see what you did so far. You created namespace. You created deployment. Where is the deployment? And now third important one, you are creating service. Okay, one by one we'll have to cover. All these are the important one. All these are in the production, by the way. Okay, so here I am going to create a service, but service. After that, I don't know. -h. Now, what is this? I did kubectl create service. I want to create service, but what is this? I don't know. So we need to know first this one, then we can create a service, because we don't know right now what is the clustered IP, because without that I cannot move. We cannot move. So here, what is the cluster IP? What is the external name? What is the load balancer, node port? These three I'll talk about now. I will leave up to you, this one, to explore yourself only, also as a task. Okay. So what is this? So let's understand first this. So did you understand that I wanted to create a service using the create command, but I got something which we don't understand, so we have to understand. Okay, so now we need to understand these options. So guys, let's understand here, and please guys focus on this is the most.
Voice is breaking.
Rajesh, not able to hear you.
Here this
Rajesh?
is the cluster.
Rajesh, can you hear us?
Rajesh, your voice.
Yeah, just a second, give me. I'm just checking my internet connection. Yes, I can hear you. Hello.
This conference will now be recorded.
Not yet.
No, type something. Type something.
No, it's not. It's a old which you selected load
No,
balancer.
should say.
Just a second, guys. I think evening we get not good experience. Suddenly something happened and internet becomes slow. What about now? Is that okay?
Yes.
We see
Yeah.
paint now.
Yeah, good. Can you see I'm just writing some paint
Sure, yes.
line?
Yes. Cloud kind of stuff.
Okay, great. Yeah. Okay, sorry about that. So here, this is the cluster, and cluster have a two node. Okay, there is a node 1 and node cluster worker. Worker has IP address also, physical IP address. This is one more worker. This also is having IP address. Okay. Now you understand that there is a two kind of pod we are running. One is a front end, one is a back end. Simple scenario. So front end pod is this one. And here, this is the red one is front end pod. Pod also has IP address. And backend pod 2, we have a IP address in blue. Guys, so far it's so good.
Yes.
Guys, I am somewhere outside of the cluster. Okay. So forget about the outside communication. First thing, this is the back end. And this is the front end. So here, first thing, front end need to talk to service, back end, right? Correct now?
Yes.
Front end need to talk to back end. So what I will do, I'll create one service. Remember, service, I created one service from the back end. This is the one service. Okay. Through the back end, we created one service. Okay. Service we created, you know, this service, the one which I created, the also get IP address, because service also get IP address. But you know one thing, this service IP address scope is only limited to cluster only. Understand that? Only limited to the cluster only. Guys, did you understand this?
Yes.
This service, understand that, very simple statement I'm making. A service which you create, scope of the service by default is a cluster only, and that service we call it clustered IP service. Clustered IP means the service which get the IP from the cluster only. Simple. Guys, are you able to understand this?
Yes, it's internal service.
It's a service. IP address of the service is part of the cluster. That means this service is accessible anywhere in the cluster. Why? Because this service get a cluster IP. That's the reason. Remember, there is a pod. This gets the cluster IP. That's the reason they are able to load balance. This service and this pod is in the same network. You know the load balancing rule. You have to reach out to the IP address. So it's in same network. Are you getting my points?
Yes.
So this service is called
Cluster IP.
cluster. Yeah. Now, guys, there is a problem. Now what will happen before that problem? Let me tell you here. This front end will talk to this service. This front end will talk to this service, and front end will talk to this service, and then this service will decide it should go to here or here. Simple. So now things are clear. But the question is, how do we reach to the front end? So guys, yes, for front end also we need to create one service. Okay, front end also we need to create. Let me change the color. For the front end also we need to create one service. This is the service. Again, the service by default, it's a cluster IP only, because that's the reason they are able to load balance, right? If it is not a cluster IP, this pod will not be load balanced. So now this service is a place where we hit. See here, if I'm inside a cluster, okay? This is me. I'm inside a cluster. I will hit this service. This redirect to one of the front end. Front end will redirect to this service, and this redirect to one of the back end. Are you getting this flow?
Yes.
Yes.
Right? As many similar kind of pod you have to create a service. The service is a cluster IP only. That understand that cluster IP only. Okay, that's the reason they are able to load balance cluster IP only. Now the problem is not the cluster IP. The problem is, how can I access from outside? That's the problem. How can we access from outside? That is a problem. So guys, in Docker, I think we did something for this workaround. What was that?
Expose import.
Using expose import.
Right, yeah, something we have to do here also. Everyone uses this concept, guys. Everyone uses this concept, right? So we have to do same thing. What we'll do, this service will exposed at the node port. Understand that. I should get you the different color. This service will expose to the node port. This one, a node port. Okay, or I think sorry, this service I need to expose. This service need to expose with a node port. So when you expose at the node port, now you can access this at the node IP address. Like a Docker, we did it. I can access this at the node IP address. Are you getting my points? Remember, in Docker also, there was the Docker network and host network. Both were in a different network, right? So both were connecting through the bridge. So here also something similar. Kubeproxy is nothing but a bridge. So here we need to expose this service to the node. Exposing this service, cluster IP service, to the node port, that is called node port. Did you understand that, guys? Guys?
One service is exposed to all nodes in the cluster.
Yes, each node at the cluster. The service will be exposed at each node of the cluster.
Okay, Rajesh, I have a question now. In case we have 10 nodes, all the 10 nodes will be added over here?
Yes, that's correct. 100% correct. Not even 99. Yes, all, including master.
That's right. Yeah, fine.
Yeah, guys. Hello.
Yeah, that's
So
understood.
Rajesh,
So all the nodes should have.
I actually have a few questions, if I may.
Yeah, please tell me.
Okay, first, I understand that service either is a pod running in itself, probably part of proxy or something like that, or is an underlying process. If you have like thousands of pods running, it is not possible that the service that is doing the load balancing would require also high availability itself.
Yes, service is basically high availability. So here you see one service got created for the backend, one service got created for the front end. But the problem is not that high availability. The problem is how can we access the pod which is lying at this service. That's the problem. So I can access.
Yeah. Mm-hmm.
Yeah, the problem is that one. So I can access host. I cannot access this service because this service is on a pod network. But this network, this node network is not on the pod network. It's on a physical network. So I can access that. For example, I can access this machine, but I cannot access the IP address of the pod from outside.
But
So
expose service, you say that it exposes on the host network as well.
Yeah, host network. That's called node port. That's called node port. The process. Yeah. Okay. See here. Pods. Okay. Here it create. Let me write it. It create a service. Load balancing. A pod on pod network. There's a two network, just like a container also we have a two network. Now what exactly this is doing? Node port, it create a service of clustered IP and expose that service to node port of the node. That's the reason we call it node port. Are you getting guys?
Yes.
Yeah.
But guys, there's one more.
Still I have a question.
Okay, just give me 5 minutes. Let me complete again. I'll repeat the things. Okay, because if I continue, maybe I'll continue confusing you. Okay, but there is one more problem.
No.
There's one more problem here, and the problem here is, guys, I will never ever hit to the IP address of the node. How can I hit the IP address of node? So what we need here, we need one external load balancer here. This is a real load balancer. So now this load balance with this and this. I will hit this load balancer. It will redirect here or here and followed by rest of the things. Now what do we call it? This is called third one, load balancer. So what happened? Let me tell you. Load balancer create one clustered IP service, then exposed at node port, okay, and node get balanced by external load balancer. See here. So first, how we are traversing. Let me recreate this image one more time. See here. What happened? There's a two network, guys. One is a node network. Understand that. And there is a pod network on which the pod runs, node network which I can communicate. So here what has happened? See that. Let me recreate this image once again from scratch. there is a host. Understand this, there is a host, there is another host worker. Okay, so I will create a load balancer for this, and I will hit this IP address at certain port. This is me. I will hit this load balancer. So this is clear, right? I'm not talking about the content pod right now, Kubernetes right now. This is clear, right?
Yes.
Okay, this is clear. Now you see here, there is a one pod running, one more pod running, one more pod running, one more pod running. All are front end. Forget about the back end because you understood those stuff. Front end. So what is happening? There is one service got created. This service is in the clustered. All this is load balanced by this service. This service is on the same network as the pod. This service will expose. You did this expose in the Docker also. We expose at the node port. Node port. So now you see here how this connection you travel. You connect from here to here to here to here. Again, one more time I'm saying, look at the connection. I hit the load balancer, it redirected to one of the node redirected to this service redirected to this one. Are you getting my points?
Yes, we are.
So guys, this is the three type. If you want to create a service cluster IP, then you create type IP. If you want to have a cluster IP plus node port, if you want to expose that to the node port, you create a node port. If you want to create everything, that means cluster IP plus expose the node port plus external load balancer, then you can use load balancer. So if it is not understood, I'm ready to explain one more time.
Question I had is where the service is hosted, or how is it hosted?
So this is a managed service by the Kubernetes. Where it is hosted, this is managed by kubeproxy, and kubeproxy, remember, communicate with API server to get the IP address. So all these pods and service is on the same network, whereas pod has been created by you, but service has been created, managed by you, but managed by Kubernetes. By the way, it's inline technologies and Nginx only. Did you understand, guys?
Yep.
Okay, so now I will teach you step by step, and then probably you'll understand more about it. I know this little complicated. In 2016, it took me almost 6 months to understand this concept. But again, if we talk about the networking, it will be more clear actually. So here, guys, how can we create a service? So first, let me check the service. How many service we have? So here, kubectl get svc shortcut. There is one service created. I have not created. So what is this? Who created it? What is the significance of this? What exactly this is doing? I'm not going to tell you. You're going to find it out for me. That's a task for the day. That means you're going to find it to me, and you're going to tell me during the live hours. Those who tell me, I would feel very happy, because those who find out the answer of this purpose of this service, he has understood the concept of the service. Okay. So now, forget about this service. I am going to look for my service, which is in Rajesh, and there's no service in my namespace. This is in the default. Okay. So now the question is, can I create a service? Yes, let me create a service. So here, create service, what? SVC, and what type of service? -h, cluster IP. Okay. So here, cluster IP -h. Now this is the full format. Okay, guys. So look at this. Here I'm writing. See here, I'm creating a service which is accessible only on the pod network because of this reason. And name of the service is mycs. And what is this? So guys, this is the service IP address. Okay, this is the service IP address. This this IP address, service port number, and this is the pod port number. So this is the pod port number. This is the service port number. So service port number, I'll make it 80 for your sake, and my pod is running on 80, by the way. Okay, Nginx. So this is the one. Okay, so now we can use this. So clear the screen and -n is equal to Rajesh. Guys, I created a service in my, see here, I created service. This is the service port number. Okay, you should describe all the commands, whatever you have used it, please use it. I'm not explaining those commands again and again, but request you to please use it, explain, describe, all these things. kubectl, describe, svc, name of the svc, -n, Rajesh. Guys, can you please see that here? See here, namespace, label, selector. What is selector? I will tell you a little bit later. Type, IP address of service, port number of service. At the target port, what is 80 of the port? Do we have an endpoint? None. No IP address. Right now, this service is not balancing any IP port number, pod. Okay. So when it will balance, any idea? I forgot actually. When this load balancing will happen automatically by the service?
When the code is running on the labels are matched.
When the labels of the pod is matching with the labels of service with star, the statement is not true, but still hold this till certain point. So matches, automatically load balance happen. Okay. So guys, this is a service I created. Okay. Now what is a label? So -, show, LEBEL is labels. You can check this. I think I'm doing some spelling mistake here. Strange.
Get now? kubectl get.
Yeah. What is this? See the labels. Okay. Now can I create a pod? kubectl get pod. See, so many pods are there. What I will do, I'll delete this deployment. I need only one pod, by the way, just for the demo slowly. Okay, so delete, deploy, -n, Rajesh, mydep. Deleted. See, got deleted. Now, can I create this pod? Kubernetes cd Rajesh here. So kubectl create -f. I'm creating only one pod, okay? Rajesh. I created. Pod is running. Can I see the pod labels also? Show labels. Here it is. Look at these labels. So this is the labels. Now this is the labels, and this is the SVC. Look at this. I've created one SVC and describe this SVC also. My-cs. Look at the endpoint. Okay. So now what I'm going to do, because label has to match, no? Here you have labels. The pod is running with app web server 2, and here labels is app-mycs. So it's a different, right? So either you modify this one or this one, anything it will work. So let me modify the pod itself. Okay. So pod only, I'll modify this label. So vi pod.yaml, and here I modify cs, and I modify the cs. Okay, clear the screen. See that, apply this kubectl, apply -f pod1.yaml -n Rajesh. I did this. Can I see that pod? See, pod labels is matching. Service labels is also matching. Okay. Service level is matching. So is it load balancing is happening? See here.
And Rajesh, can you open that pod XML in that something called labels? So what is that used for?
That's a label, no? That's a label.
No, but we change the app name. Mukunda speaking.
I changed the label, no?
No, open that pod.xml, open. There's something called labels on top of it. App equal to mycs, you made it, but above labels there. Because if you define the label name there, what happens?
That's a field, no?
Okay.
Field value, field key value.
In case you put labels, means value of the labels equal to mycs, what happens?
What you are saying, I'm not able to understand.
No, to match the label name, you change that app name to my.cs, right? my-cs.
Right, right.
In case if you define label itself as my-cs, what happens? The label, what you're supposed to do?
This one?
Yes.
This syntax error will come, no? Because it's a field. You're getting my points. Field.
Okay.
YAML field.
Okay.
It's a field. This is the field. This is the field. So label should be in a key and value format always. Okay. It's a YAML file.
Okay.
Okay. So guys,
Fine.
but still it's a wrong thing actually. You have understood the wrong perception. See here. Look at this endpoint got updated. Now that's a pod IP address. Like let me first do this. See here. Labels matching, but actually it's a wrong perception. Wide. See here. If I do curl http pod, and can I see the service label? Service curl http. Why it's not accessing?
Pass 8080.
Yeah, 8080 service access. But guys, you know one thing, we learned the wrong thing. Now I've been telling you, I'm teaching you a little bit wrong, which I'll correct it during the demo. So actually I was telling you, I'm writing it, okay? if labels of pod is matching with labels of service, automatically pod get updated and load balancing happen and updated to service. That's all. Actually, this is a wrong statement. Wrong statement. So what is the right statement? Actually, the right statement is if the labels of pod is matching with the labels of with the selector label. Yes, selector label of SBC, then actually it happens. This is right. Now you must be wondering, what is the selector label? Let me show you here. Let me show you here. So here, get SBC and describe SBC. See here, this is a selector label. Actually, it was matching with the pod actually. That is the reason, because of this load balances happened, not because of labels of pod, labels of service. So what labels of service, it's not effective here. So here what is happening, this service is saying select all the pod which has this label. Selector means select all the pod to this endpoint which has this label. Okay, so let me prove this point. I will change this selector, and for that I need to edit service. I'm changing the selector only. Okay, go. I'm not changing the labels. I'm changing the selector only. I think I'm losing a little bit energy. 1. Okay, and I just change it, and now can I call that service? See, so now is this the correct statement? So please remember, labels of pod should match with the selector label. This is a selector label of the service. Then automatically the load balancing happens. So now let me show you one more pod. So here I'm creating one more pod. I have to change the name of it. Here kind is equal name is equal to Rajesh1, and let me create one more pod, kubectl create -f pod 1. I created one more pod. You see that kubectl. Okay, did I create in the, sorry. So here I created one more pod, get pods -n is equal to Rajesh, and you see 2 pod is there. Can I see that labels? Show labels labels. See, the labels are matching. So, but can I describe the service? See that no endpoint. Look at the only endpoint. But what I will do, I edit the service again. Look at this. Here I'm doing the service again, and I recorrect this with the selector label. Whatever, I'll restore that selector label. Where is that? Here it is. I'll just reconnect, and I'll change this label because I don't care about the service label here. I don't care because it's not impacting to my load balancing. 444 something like that I added. See here, and now see 2 pod. Did you see the magic?
Yeah.
Did you see the magic? Now, like that, you have a 2000 pod. But if selector labels are matching with the label of pod, automatically load balancing happens. You don't do anything. You don't do anything. And now you see here, curl service pod, service IP address. See, one of the pod actually. I don't know which one, but you should go. I should have created one blue, green, something like that. It was there, but I'm not able to recollect the images. So it's like this. So guys, this is the stuff which I tried for seeing the service. Now node port is the one which I'll explain it to you a little bit later. I mean maybe tomorrow, and load balancer. Okay. So guys, what you have to do, you have to do deployment, finish the deployment which is pending, then create a service, understand this, understand the labels and all, recall all the discussion, because again if you forget, again you back to the same place. So you have to do this again, and you have to try all these commands which I have shown you. And top of that, task for the day is you have to tell me, you have to teach me, if you really understand that, if all commands you know that for sure, I know that you have all the commands already. It's just you have to think and have some sort of discovering mind. So get svc hyphen what is this service and what is the use of this service, how this service is helping us, for what. So if you can tell me, this is a task for you, that will be great. Make sense? Any questions, guys?
Yeah, Rajesh, when we created service, you did not give values for label or selector label, right? It automatically made the name of the service as label.
So by default, you can give it actually by default whatever the name of the service, by default it has taken, but you can give any name also. It's up to you. You can change the label. There is a command for changing the label, is label. I did not talk about it because I don't want to confuse you too much with the too many things at a time. There is a command called labels. See here. Okay.
Okay.
So you can, by default they take it, that's a default behavior, but you can modify if you are, typically I am doing, I created a service through the command line, right? But typically we'll do through the YAML file. There you control all this thing. More questions, guys?
Rajesh, is this network port will take time?
A network port, which network to?
Network ports.
Sorry, I'm not able to understand you.
No, for the services, there's a network port service, right?
No, it will not take time. It will just a matter of blink of eyes.
Okay. Why? Because now we are very clear with the theory. Like if you tell later, probably we need to recollect the theory, what it is.
No, that's the reason I'm not covering the node port. Others you'll get hodgepodge. I know that previous experience, many people get lost. So that's the reason I'm not completing the node port. You do this cluster port properly, then we'll talk about the next.
I think I know what the Kubernetes service is for.
If you liked our Kubernetes session so far, please enroll for our channel membership $399 plan to get access of all the parts. Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.